Let's learn properties of logarithms. Here's 3 rules we're going to learn: the product rule, quotient rule, and the power rule. These are rules that we can use to expand or condense logarithmic expressions. The log of two things multiplied together can be expanded into log of the first thing plus log of the second thing. That's in words what the product rule says. So the log of multiplication can be expanded into log of the first factor plus the log of the second factor. As with any property, we can read this from left to right or from right to left. Let's do an example. In this example, we have log base 3 of a product. The product is 6 times x. We can use the product rule to expand this into log base 3 of 6 plus log base 3 of x. The next rule is the quotient rule. It says the log of two things divided can be expanded into log of the first thing minus log of the second thing. Again, we can read this rule left to right or right to left. If we go from left to right, we're expanding the logarithm. If we go from right to left, we're condensing the logarithm. Let's look at an example. Here we're taking the log base 8 of a quotient, two things being divided. Using the quotient rule, this can be expanded into log base 8 of 23 minus log base 8 of x. Notice that the negative goes with the part coming from the denominator. This would be incorrect if I did log base 8 of x minus log base 8 of 23. The next rule for logarithm is called the power rules. This rule tells us the exponent can be moved out front as a coefficient, which is reading the rule from left to right. Additionally, we can read this rule from right to left, which says if we have a coefficient in front of the logarithm, we can move that inside as an exponent on the argument. Let's use the power rule to expand the logarithmic expression given to us as an example. In this case, we have log base 6 of x to the second power. Using the power rule, we can take the power and move it out front as a coefficient, which will give us 2 times log base 6 of x. Compare these two expressions. The one on the left is a candidate for the power rule. We can take that exponent, move it out in front as a coefficient, and get 2 times the log of x. The one on the right is not a candidate for that. The one on the right is saying log of x squared, which equals log of x times log of x. This is not the same thing as 2 times the log of x. The one on the right is log of x squared. So the power rule only applies when the exponent is on the argument, on the inside, not when the exponent is on the outside. Sometimes we'll write the one on the right as log with the exponent in this position when we mean log of x squared, the whole expression squared, to avoid the confusion from the one on the left. Let's do an example where we combine several of the properties. Let's use the properties to expand this logarithmic expression as much as possible. You might be thinking about using the power rule for your first move. However, we cannot use the power rule unless the entire inside, which we could call m, is raised to the same exponent. Over here, the exponent of 4 is only on part of the input, not on the entire input to the logarithm. Therefore, the power rule does not apply. Instead, we can apply the product rule first. We see that this is the multiplication as the argument of the logarithm. Therefore, we can use the product rule to expand this as log base b of the first factor plus log base b of the second factor. Now, there's a single exponent, so we can apply the power rule. Also, let's look here. The cube root of y is the same thing as y to the 1/3 power. So instead of writing cube root of y here, let's write y to the 1/3 power. Now we have a single exponent for each logarithm, so we can apply the power rule and move those exponents out front as coefficients. And that's all we can do, so this will be our final answer. This has expanded the logarithmic expression as much as possible. In this example, we're asked to condense the given logarithmic expression. We're asked to write the logarithmic expression as a single logarithm. So now we need to apply these logarithmic properties in the right to left direction. If we move from right to left, we're condensing. Before we can use the product rule or quotient rule, we have to make sure that there's no coefficients in front of the logarithm. The first logarithmic expression has a coefficient, so we can move that inside as an exponent. The second logarithmic expression also has a coefficient, so we can move that inside as an exponent. The last logarithmic expression does not have a coefficient other than 1, so we don't need to do anything with that. Next, we can apply the product rule on these two logarithmic expressions because they're being added together, which gives us ln of x squared times x plus 5 to the 1/3 power. We still have the minus ln y. Next, we can condense these two logarithmic expressions. They're connected by subtraction. Therefore, we need to use the quotient rule. The quotient rule says to divide the two arguments. So this will be the numerator and this will be the denominator. Notice how we have a single logarithm. It's not log of the numerator divided by log of the denominator. It's a single logarithm whose input is a fraction. We've completed the objective of writing the expression as a single logarithm, so that's our answer. Here are some common mistakes to look out for when you're trying to simplify logarithms. Notice there's no property that says logarithm of an argument added or subtracted can be simplified. Notice if you have log of two factors, this is not equal to log of the first factor times log of the second factor. Instead, it equals log of the first factor plus log of the second factor. Notice that log of x over y is not log of x divided by log of y. Instead, the quotient rule tells us is log of x minus log of y. Notice that log of x over log of y is not equal to log x minus log y. Instead, log of x minus log of y is equal to log of x over y. Notice how there's only a single logarithm, not two. And finally, we can't apply the power rule unless the entire inside has the exponent. In this example, the k exponent is only on y, therefore the power rule does not apply. In this video, we learned how to use logarithmic rules to expand logarithmic expressions and condense them.